Hello everyone, I'm Jin Yang from Duke University. I'm very happy to present our work, Mixture Outlier Exposure towards Out-of-Distribution Detection in Fine-Grained Environments. In this work, we study the problem of OOD detection. Most existing OOD works focus on coarse-grained settings where OOD samples are unsimilar to in-distribution data, and OOD detection in fine-grained settings is largely underexplored. However, we argue that fine-grained detection could be more challenging and realistic. For example, imagine when a bird classifier sees novel bird species, the high semantic and visual similarity can cause great difficulty for detectors. Meanwhile, many application scenarios like remote sensing inherently have fine-grained attributes. So in this work, we aim to closely investigate OOD detection in fine-grained settings. What we first do is that we carefully construct 4 fine-grained OOD test environments by partitioning public fine-grained datasets. Basically, we randomly select multiple categories as in-distribution and hold out the remaining ones as fine-grained OOD. We then evaluate several popular methods and find that fine-grained nowadays are significantly more difficult to detect compared with coarse-grained OOD samples. More surprisingly, we find that no evaluated methods improve upon the simple baseline MSP against fine-grained OOD, even including the ones that use outlier data during the training. So given the initial evaluation, we proceed to analyze why fine-grained detection is difficult. Basically, we visualize data representations in DNN latent space and find that fine-grained OOD data can be much closer to in-distribution clusters compared with coarse-grained ones, which explains why they are harder to detect. Furthermore, the training outliers only cover the coarse-grained OOD region but not fine-grained OOD region, which explains why outlier exposure-based methods do not improve fine-grained detection. So to address this issue, we propose a training algorithm called Mixture Outlier Exposure. The high-level idea behind MixOE is to explicitly expand the coverage of training samples over the fine-grained OOD region. We achieve this by mixing in-distribution and training outliers to generate virtual samples. In this work, we adopt simple pixel-level operations such as linear mixing and cut-paste mixing. As you can see, the generated virtual samples can either be ID or OOD or any of the intermediate state depending on the random coefficient lambda. Correspondingly, we assign soft target to each virtual sample by convex combination between the one-hot label and the uniform distribution. By doing so, we can control the prediction confidence to smoothly decay when the input transitions from ID to OOD. Finally, the overall training objective is just to minimize the cross-entropy loss on those empirical samples from the original training set and those generated virtual samples. For the results, we find that our MixOE is the only method that consistently improves both coarse and fine-grained detection across the 4 benchmarks. Also, MixOE works well with either linear or cut-paste mixing, which demonstrates the effectiveness of the general idea behind MixOE. So to conclude, we construct 4 large-scale test environments for fine-grained detection. We propose MixOE, a novel OOD training methodology that has effect for both coarse and fine-grained OOD samples. We hope that our study can inspire more works towards fine-grained OOD detection. And lastly, if you'd like to see our code, you can scan this QR code. Thank you.